You know, the light that's warming your face right now? It started on a journey that is almost impossible to imagine. So today we're going to follow a single packet of energy, a photon, from its violent birth deep inside the sun's core, through its million-year struggle to escape, and finally, its leap out into the vastness of space.
Okay, first things first. To really get a handle on this journey, you have to appreciate the sheer scale of the sun. And this number, well, it says it all. The sun makes up 99.9% of all the mass in our entire solar system. Everything else, all the planets, moons, asteroids, were all just the gravitational leftovers. The sun is the undisputed center of our world, a giant held together by its own crushing gravity.
And power station is exactly the right word. It gives us the warmth and light that makes life on Earth even possible. But, it's not all gentle. It's also constantly blasting out particle radiation that, creates those beautiful auroras, but can also be a real hazard for our satellites and for astronauts out in space.
So what is the sun actually made of? Well, it's not a solid rock, and it's not fire like you'd see in a fireplace. It's a massive sphere of superheated gas called plasma. The temperatures are so insane that atoms of hydrogen and helium get torn apart, separating their electrons from their nuclei. It's this super hot electrified soup that fuels, well, everything.
All right, so let's dive right in. We're starting our journey where all the action begins, the core. This is the absolute center of the sun, and it's an environment that's totally unlike anywhere else in our solar system. I mean, the conditions here are just mind-boggling. The temperature is hovering around 27 million degrees Fahrenheit, and the pressure from the weight of the entire sun pushing down on the center is just enormous. And this exact combination of intense heat and crushing pressure, well, that's the secret recipe for the sun's power. And that power source is called nuclear fusion. This is the engine of the sun. Deep in the core, hydrogen nuclei, which are really just single protons, are moving so fast and are squeezed so tightly together that they overcome their natural instinct to repel each other. They smash together, form a totally new element, and bam, a massive burst of energy is released.
This whole dance has a name, the proton-proton chain reaction. As you can see, it starts when two protons fuse. Then another proton joins the party. Finally, two of these new things combine, and the end result is a super-stable helium nucleus and a huge burst of energy in the form of a gamma-ray photon. And right there, that's it. That's the birth of our photon.
Okay, so our little packet of energy has just been born. Now, you'd think it would just zip right out of the sun at the speed of light, right? But oh no, its journey has barely even started, and it is going to be an incredibly long and difficult one.
Its first obstacle is the radiative zone. I want you to imagine trying to get through the densest, most packed crowd you've ever seen. You take one step, you bump into someone, and you get sent off in a totally random direction. That is exactly what happens to our photon. The plasma here is so dense that the photon gets absorbed by a particle and then shot out again in a completely random direction. It's like a cosmic pinball machine. And this random, drunken walk takes an absolutely mind-blowing amount of time. It could take up to 1 million years for that single photon to finally pinball its way through the radiative zone. Just think about that. The sunlight hitting your face right now was generated in the sun's core when our distant human ancestors were first walking the Earth. So, after its long stumble through the radiative zone, our energy finally reaches the convection zone. And here, the way it travels changes completely. Think of a big, bubbling pot of water on the stove. Hot blobs of plasma physically rise to the top, carrying our energy with them. Then, at the top, they cool down, release the energy, and sink back down again. It's this constant churning that finally brings the energy to the sun's surface.
And this is it, the big moment. After maybe 1 million years trapped inside the sun, our energy finally rides one of those convection currents to the top and just breaks free into space.
This surface has a name. It's called the photosphere. Now, it's not solid ground we could stand on, of course. It's a layer only a few hundred miles thick where the sun finally becomes transparent. And this is the point where our energy is finally released as the sunlight we all see. When you look at the sun, with proper eye protection, of course, this is the layer you're actually seeing. But hold on, the journey's not quite over yet. Beyond this visible surface lies the sun's vast, ghostly atmosphere. But it's usually completely invisible to us, just totally washed out by the incredible brightness of the photosphere. So how on earth do we ever get a look at it? Well, during a total solar eclipse. It's just like the quote says, when the moon perfectly blocks out the bright face of the sun, these faint, ghostly outer layers of the atmosphere are suddenly revealed in this absolutely spectacular display.
The very first layer of this atmosphere is called the Chromosphere. It gets its name from this amazing reddish color you can only see during an eclipse. And this is where things get really weird. Because even though we are now moving away from the sun's core, the temperature actually starts to go up again.
And this, right here, lays out one of the biggest head-scratchers in all of solar physics. Just look at these temperatures. The surface, the photosphere, is a little under 10,000 degrees Fahrenheit. But the outermost atmosphere, the corona, is millions of degrees hotter. That makes no sense, right? It's like walking away from a campfire and suddenly feeling hotter. It goes against everything we think we know.
So what is going on here? How can the atmosphere be hotter than the surface? The honest truth? Scientists are still working to figure it out completely. The leading theory has to do with the sun's incredibly complex magnetic field, that it's somehow pumping massive amounts of energy up into the corona, superheating it. But the exact how is still a huge area of research.
And so, for the final stage of its journey, the superhot corona thins out and basically leaks into space. This constant stream of charged particles flowing away from the sun is what we call the solar wind. It travels across the entire solar system, interacts with every planet, including ours, and it's what gives us those beautiful northern and southern lights.
So let's just recap this incredible trip we've been on. An energy packet born from nuclear fusion in the core. A random million-year walk through the interior. A final burst of freedom as visible light from the photosphere. And then a final trip through an atmosphere that, for reasons we're still trying to understand, is hundreds of times hotter than the surface itself.
And that leaves us with this one last, kind of mind-bending thought. The sunlight we see today is ancient history from the sun's core. And it really makes you wonder, what information, what secrets about the sun's deep past are just now beginning their million-year journey to the surface?